Today, we're gonna make a sand shader in Unreal and Unity. Let's go! So before we work on the shader, it's always good to learn a little bit about the material we're trying to create. So let's take a look at some reference images. The main thing that I notice from this image is that sand has many levels of detail. At a really zoomed out level, we have these really large dune shapes. And then moving in just a little bit closer, we have kind of these medium-sized dunes as well. And then as we step up even closer to the sand, we can see that we have these ripples on the surface that are created by the wind. And then as we go all the way into kind of a microscopic level, we can see that sand has individual little grains as well. So sand has several different sizes of detail that we need to consider. Now, in our project today, we're going to be focused mainly on the material part of the sand, which includes these ripples and grains. But for the details on how to create these larger dune features, I'll link another tutorial video down in the description. So I did grab a couple of other images here that we can take a look at as well. This one does a good job of showing off these large dune shapes and also just a little bit of the wind ripples here. And then here's another one as well. I really like this one because of the cool wind ripple patterns that we get to take a look at. And finally, as I said, when we zoom in really close, we can see that sand is made of these individual grains of silicate or glass. And when we create our sand material, we're not actually going to be zooming in this close to the material, so we don't actually have to create the appearance of all these different individual grains. But we do need to make it look like the grains are there, or hint at the idea that the sand is actually created out of grains. So I'll show you how to do that in a minute once we get into it. So a really easy way to get started with a project like this is to open up Quixel Bridge and see if there are existing sand materials already. So let's take a look at that. We'll switch over to Quixel Bridge, and you can see that I've brought up this sand material that's called Bright Desert Sand. Let's take a look at this. You can zoom in here and you can see that this particular material does a really good job of capturing sort of these wavy patterns that the sand creates on the surface that are caused by the wind blowing across the sand. So we'll go ahead and download this material, or if you have other material libraries, feel free to go ahead and grab whatever sand material that you like. So first, before we start creating the shader, I want to jump into Photoshop and show you the textures that we get when we download this sand material. All right, so here we are in Photoshop, and we have our color sand texture, our normal map, our ambient occlusion, and our roughness map. And what I'm seeing from taking a look at these textures is that there is a lot of room for optimization. First, let's take a look at our color texture. If we zoom in here, you can see that this texture is basically just one color, but that there are all these little tight details on top of that color. So anytime you see a texture like this that's basically just a single shade or a single hue, it's a really good candidate for the optimization technique that I'm about to show you. What we need to do is split this texture into a single channel detail mask and the color. So the way that I'm going to do that is I'm just going to make a copy of this texture. And now I'm going to use Photoshop's tool to desaturate it. So I'll come under here, under Image, and pick Adjustments, Desaturate. And now I've captured basically just the tight details. And then the other thing that I need to do is grab the color. So I'm going to make another copy. And in this version, I'm just going to add a blur filter, just a Gaussian blur, and I'm going to turn it all the way up to 256, and it basically just turns the texture into a single shade. And then I can use the eyedropper and just sample here somewhere in the middle, and I've captured the base color of this sand material. So now what I need to do in the shader is take this detail that I've grabbed and overlay it on top of a static, like hard-coded color value, and I can basically recreate what I've got here with this texture, but with just a single channel. Before I do, I need to do a little bit of processing on this detail channel, or this detail texture here, to turn it into something that I can overlay. So what I'm going to do is come up here under Image Adjustments and pick Levels. And now I need to adjust my levels so that this little center handle is centered right in the middle of the highest peak of my detail. So I'm going to grab my left handle here and just kind of slide it over. And maybe I'll move my right handle just a little bit as well until my center handle is centered right in the middle. And the reason that I want to get it in the middle is that the way overlay works is any detail in this texture that is brighter than 0.5 is going to brighten my texture, and any detail that's darker than 0.5 is going to darken my texture. And so I need an overlay mask here that's nice and balanced right in the middle. So this middle mark here represents where 0.5 is going to be, and I need that to be right in the center. So I'll just go ahead and click OK to apply that. And now what I'm going to do is I'm going to simulate what the shader is going to do, but I'm going to do that here in Photoshop. So I'm going to take this texture and I'm going to overlay it on top of this solid color here. We'll just paste this layer in. And then if I go to my blending type, I'm going to drop this down and set it to overlay. So now you can see that this single channel, like black and white detail texture, has been overlaid on top of that single color. And what I end up with is something that is very close to the equivalent of my original texture, but I'm just storing it in a single channel. Can you see how that's an optimization? So I don't have to store this whole color texture here as its own texture. I can just store this single channel here in with another texture and not have to save my color map at all. So that's a pretty cool optimization. All right, let's take a look at some of our other textures here. So I think the star of the show really is this normal map. It's got these great wind ripples. It's got some little tight pebbles and other details here. That looks great. So we're going to keep that. However, if we take a look at our channels, all of the information of this normal is basically in the red and the green channel. I do have just like a tiny bit of information here in the blue channel, but I can do some math and recreate that in the shader. So I don't actually need to store this blue channel data. What I can do instead is I can take this detail grayscale image that I created from the color map and copy it and paste it right into the blue channel. So now I have something that no longer looks like a standard normal map, but it has the normal map's X and Y offsets in the red and green channel, and it has the color overlay detail map in the blue channel. So now with this single texture, I can represent the entire material of the sand. That's pretty cool. The reason that I can do this, if we take a look at our ambient occlusion map, I mean, this is basically just white, right? There's no detail in this map at all. So storing that somewhere and putting it into the game would be a big waste. And it's basically the same with the roughness mask. This mask basically just boils down to noise. And I'm gonna imitate that in a different way, which I'll show you just a bit later. So really all I need to do is take this map and bring it into Unity and Unreal, and I can have my whole sand material with one texture. All right, so let's jump into Unreal and I'll show you how to do that. All right, so the first thing that I want to show you here in Unreal is I have this really nice sand dune scene, and I will link down in the description the tutorial that I used to create this. It's a really nice one, so if you want to create a scene like this, go ahead and follow that tutorial and then come back and I'll show you how to improve the material. So this material that we're looking at here is the one that was created by Quixel Bridge. And like I said, it's using 4 texture samples. If we take a look at Quixel Bridge's shader here are the 4 textures it's sampling: albedo, metalness, AO, roughness and displacement, and normal. And we're not using metalness, and we really don't need AO and roughness textures based on what we learned by looking at the textures in Photoshop. So we're doing 4 texture samples here when we don't really need to be. Additionally, if we take a look at kind of a close-up on our sand, it kind of gets blurry when we're looking at it close. So we need to do something in our material to create the look of these grains. So what I'm going to do now is I'm going to switch over to the shader that I created that's only doing the 1 texture sample plus 1 additional detail texture that I'll show you in a minute. And what I want you to see here, I've improved the specular here. This one is just doing 2 texture samples instead of 4. And when we zoom in just a little bit closer, you can see that there's extra detail here representing the graininess of the sand. So again, you know, if we just kind of get in a spot like this, here is the one that we're going to make together. And here is the version that Quixel Bridge gives you just by itself. So let's go ahead and jump in and we'll build this improved shader together. All right, the first thing that I need to show you is this texture that we just created in Photoshop. So what I've done here is I've imported it into Unreal, and there are a couple of settings that are really critical. First of all, make sure that you uncheck sRGB here so that this data is stored linearly. And then second, make sure that your compression settings are set to BC7. Sometimes these kinds of maps are saved as normal maps, and we don't want that. We don't want the engine to know that it's a normal map, because otherwise it's going to do some processing on it that we don't actually want. So we're going to save this as BC7 with sRGB unchecked. And now we can go ahead and create our shader. So I'll open our content drawer here. I'm just going to come down to the bottom, right click and create a new material, and I'll just call this sand. Looks like we already have sand, so I'm going to make sand 2. And I'll just open it up, and now we're ready to get started. So let's first bring in our texture sample. So here's a texture sample node, and I called the texture sand underscore Unreal NC. And if you'll remember, this texture contains our color data as well as our normal data. So let's work on the normal data first. What we're going to do is we're going to take the red and green channels and we're going to append them together into a single vector. And now what I need to do, since this is not stored as a normal map, since I didn't tell Unreal it's a normal map, the first thing that I need to unpack this normal map data is to multiply it by 2 and subtract 1. And that takes the data from texture space, which is 0 to 1, into vector space, which is -1 to 1. So I'm going to multiply by 2 and subtract 1. I think I do this operation on just about every tutorial, so hopefully you guys are catching on here. And the next thing that I want to do is add a derive normal Z. And what this is going to do is it's going to take that X and Y channel and automatically generate the Z component of the normal. So now what I've done here is basically just unpacked the normal from the red and the green channel, and now I can just plug this into the normal input pin on my root node there. And you can see that I've successfully recreated the normal, those nice ripples from the sand. Now what I want to do is, when I put this on the terrain, I discovered that the texture coordinates on the terrain are set to, so a value of 1 for texture coordinates, or a tiling value of 1 is 1 meter. And so there are a ton of ripples here in just 1 meter, and this kind of scaled down too small to work correctly on the terrain. So what I want to do here is just bring in my texture coordinates, and I want to multiply them by 0.1, and that takes that meter scale up to 10 meters. So I'm basically saying the ripples on my texture, or this texture map, represents a 10-meter area. So let's go ahead and save that. And we'll switch over to our scene here. This is the final result, but I'm just going to go ahead and grab our Sand 2 material so that we can take a look at the results we're getting all along the way. All right, so right now we have nice normals for dunes, but obviously we haven't added any color in here, and we don't have our detail in yet either. So let's go ahead and work on the color next. Now remember, I have the detail data stored in the blue channel here of my texture, and I need to bring the color in from Photoshop. So if I switch back here to Photoshop, this color that I used, I can just go ahead and sample that, and I'll bring in that color here. And now I need to use overlay. So if I open up my searcher here and grab an overlay node, I'll just use blend overlay. So this is my base color. And then what I want to overlay on top of it is that detail data that I stored in the blue channel. So I'll just grab that blue channel and wire it in. And then I just need to take my result and drag it over into color. So now I've got my color recreated. So instead of storing my color in its own separate texture, I just put it in that blue channel, the detail data, and then overlaid it on top of a static color value. So now when we switch back to our scene, now we have the color of the sand. And it looks pretty good when we look in this direction, but our shininess is kind of killing us right now. That just doesn't look very realistic. So let's go ahead and fix that. Well, one way to fix it is we can just turn down our roughness. So I'm going to hold down 1 and click to add just a static value here. And for roughness, I can just, for now, I can just set it to 1. And that kind of makes the problem go away. It just kind of brushes it under the hood. The next thing that I want to, or under the rug, the next thing that I want to work on is the detail, because we have these really nice looking ripples, but when I get in close, it kind of falls apart and you can see individual blended pixels in my texture map. So for that, what I need to do is make another texture. So let's come back here to Photoshop, and I need to make basically a sand grain texture. And so what I'm going to do is just come up here to File, New. I'm going to make a new texture that's actually just for temporary. We're going to make it 2048. And I'm going to fill it with a value of 128, 128, 120, actually 127 is what I'll do. Just need a kind of a mid-gray here. And then we'll hit Alt and Delete to fill with that color. And now what I need to do is add noise. So I'm just going to come up here to Filter, Noise, and pick Add Noise. And I'm going to make sure it's set to Gaussian, and my amount is going to be 13%, and I want it to be monochromatic. All right, so now I just have a whole bunch of noise. And what this represents is, if you consider each individual grain of sand a different facet on my material, each grain is pointing a slightly different direction, right? And so what I can do is use this noise to create random normals. And so I'm just going to take my selection here, and I'm going to set it to fixed size, and I'm going to make the size 1024. And this is going to be one of the channels of my normal map. So I'll just paste that data into the red channel, and then I'll move my selection here down to the bottom, say, and I'll copy and paste this, and this is going to be my green channel, and then I'll leave the blue channel white, and bingo, now I have a noise normal map that represents each individual little grain of sand facing a different direction. So now I just need to import this texture into Unreal, and I'll import it into Unity later as well. And we can use this as our detail normals for our sand. So let's switch back to Unreal. And I've already actually imported this texture in, and here it is. You can see that I've set it to be a normal map and that I've turned sRGB off. So let's go ahead and bring that texture into our material. Just need another texture sample here, and I want the sand detail normal. And now I can take this normal and combine it with the other one. But the first thing that I need to do is get the scale right. So I'm gonna take the texture coordinates, multiply by this value, and I have a 1024 texture here. And the size of grains of sand that we're going with is 0.5 millimeter. And so what I want to do is scale this texture, or I want to tile this texture 2 times inside of a 1 meter area. And that will make each pixel roughly equivalent to the size of the grains of sand. I know it's getting kind of like technical there, but it's kind of cool that you can say, okay, a grain of sand is 0.5 millimeter. So if I multiply my texture coordinates by 1,000, now I've gotten down to the size of a grain of sand with each individual pixel here. Actually, it just occurred to me that I think the correct value is 2,000 because we're using half millimeter. So I'll wire this in, and now I have 1 pixel per grain of sand. Incidentally, if you think about this, if I have a 1024 texture, in my case, this 1024 is representing 10 meters of space on my terrain. If I have a 2048 texture that's actually representing 1 meter, it's basically the same thing as saying you have a pixel for every grain of sand. So, you know, if you're downloading 8K textures and using them for 1 meter of space, that is a massive waste because you've got like 16 pixels for every grain of sand on your... Okay, I'm on a rant here. I better just kind of lay off there, but 2048 texture for 10 meters is going to be fine as long as you have some kind of detail to combine with it up close. All right, so the next thing that we need to do is combine our detail texture in. And in order to do that, I'm going to add a blend angle corrected normals. This is going to mix the base normal here of my material texture with the detail normal of my like individual grain of sand normal map there. And I'll wire that in and hit save. All right, and now we can switch back to our desert scene. And when we zoom in, it's not going to be quite as apparent because I don't have my specularity happening yet. But let's go ahead and do that next. So what I want to do is use some of this noise that I created for my noise normal map to also be used for the roughness. So I just need to adjust it a little bit. Because it's stored as a normal map, it's had its range expanded to the -1 to 1 range. And so I'm going to undo that math here. I'm going to multiply by 0.5, and I'm going to add 0.5. And this is basically the opposite of what I did here, where I'm expanding the range. Here I'm contracting the range back down to 0 to 1. And now I'm going to add a power just to adjust the value that I'm getting. So if I wire this directly into the roughness, you can see that the value that I get is just way too blown out here. And so I'm going to give it a power node, and I'm going to set my power to 0.2 just to adjust the fall off curve of this noise data. Then we'll wire that into our roughness and hit save. Okay, I actually realized that I made a pretty big mistake here. When I was creating my texture coordinates, I multiplied by 2,000. And what I really wanted to do is multiply them by 2. And what this means, so this multiplication here by 0.1 is converting it to 10 meters. And this multiplication by 2 is converting it to half a meter. So that's mapping this 1024 noise detail texture to half a meter of the space. So if we zoom in here, you can see a little bit of what that's doing, but it looks a lot better, of course, on the actual terrain. So let's take a look at that. Yeah, so now you can see these individual grains of sand, and I probably wouldn't ever get this close, but I might get to here or so. And you can see that it's also helping with the roughness in the distance. This is some really nice looking specular highlight here from the sun that's being scattered in all directions by that detail normal. Pretty cool. All right, let's go ahead and hit play and take our little mannequin for a run here into the sunset. You can see the nice sand dunes that I've created here and the sand materials with the ripples that I got from the Quixel material. But as I said, I'm only sampling 2 textures here instead of 4, and I'm actually getting a nicer looking material because I have that really tight and noisy detail normal map. Now, if you wanted to optimize this even further, you could probably get away with creating a smaller noise texture. Mine is 1024, where each pixel is slightly different, but you probably get away with making that noise texture like a 256 or maybe even a 128, because you only see it when you get really close to the sand, and then you would just multiply your texture coordinates by 4 or by 8 to tile that a little bit tighter. So that's one potential optimization. All right, there is my sand material. Let's switch over to Unity and I'll show you how to create the same thing in that game engine. All right, here we are in Unity, and you can see that I've created a similar type of environment and that I've also created a similar type of sand shader. So let's take a look at how it's put together. Here's my sand shader, and it's basically doing exactly the same things that the Unreal version is doing. First of all, I bring in my UV coordinates, and I'm multiplying my UV coordinates by 100 to size them correctly because I'm applying this shader to a terrain. So in UV space, 0 to 1 is the entire terrain. And I'm using my terrain at the size of 1,000 meters. And so I'm multiplying my UVs by 100 so that I'll get 10 meters per texture tile. So just like I did in Unreal, I've brought in my sand texture here. And the only difference between this texture and the one that I was using in Unreal is it has the green channel flipped for the normal map because Unity uses Y positive and Unreal uses Y negative for normals. Right, so for the texture, I have it set to type default, not normal map. And I also have it set to sRGB off. So this is a linear texture. All right, so with my texture, I have my red and green channels here that have the X and Y of the normal. So I combine those together. I multiply by 2 and subtract 1 to expand those to the -1 to 1 range. And then I use the normal reconstruct Z node to create the Z component of the normal. And then I blend those normals with my detail normals. I'll talk about those in a second. So in the blue channel of the texture, we're storing the detail for the color. So up here I have my sand color, and I'm blending that using an overlay blend, blending that with the blue channel data, which is the sand detail. And that's what gives me these color details that you can see here. So the color, the shade itself, is coming from this color here, but the details, if we take a look at this channel here, you can see that, oh, well, I guess it doesn't show when it's multiplied by 100, but the details are in that blue channel there. So that's how I'm doing my color. That's how I'm doing my normal. And then for the detail normal, I use the same exact texture that that we used in Unreal. Here's my sand detail texture. It's a 1K texture with sRGB off, and normal map is set to on here. So that is actually a normal map, unlike this one. This one's not a normal map because it's storing that color detail in the blue channel. Okay, so then I take that normal and I combine it with the other normal to get my detail normals. You'll also notice that here I'm multiplying by 100 so that I get 10 meter blocks of my regular material texture. But then I'm multiplying by 20 again so that I get my detail normal texture tiled twice per meter. So then, in order to do the smoothness here, I take the red channel of my detail normal, I multiply by 0.5 and add 0.5, which gets it back into the 0 to 1 range again, and then I raise that to a power of 2. And this is a value that you might play around with just depending on what type of specular highlights you're looking for. So yeah, there is my sand shader in Unity, and you can see I've created a similar kind of scene with the desert dunes and the sand shader here applied to the terrain. All right, I hope you enjoyed today's tutorial. This was kind of a fun one to put together. I hope you learned a few things about texture optimization and detail normal mapping and just about sand in general. You know, I was kind of fascinated to find out that sand has grains that are 0.5 millimeter or less, and that we can get that exact resolution in the texture so that we get 1 pixel per sand grain. Anyway, thanks for watching, everybody. Hope you have a great week, and come back next week for more shadery goodness.